Let's now try and understand some of the properties of rational number. First is the closure property. The properties are no different. You've studied all these properties in integers, in whole numbers, etc. So we'll study the same properties, but the properties may have a different, the property may be slightly different in case of rational numbers. The behavior of that property may be slightly different. So let's try and understand what is, first of all, the closure property. What is it? Closure property specifies that if the mentioned operation is performed on the rational number, the result is also a rational number. So closure property says that after any operation, after that particular operation is done on the rational numbers, the result will also be a rational number. So yes, if we see for addition, it is true. For subtraction, it is true. For multiplication also it is true. But for division, if we say any rational number of the type a by b is divided by 0, and see, 0 is also a rational number because 0 has 0 in the numerator, not in the denominator. So 0 is a rational number. So if we divide any given number a by b by 0, the result is definitely not a rational number, because the rational number says that the denominator should not be 0. So the closure property of a rational number holds true for addition, subtraction, and multiplication, but does not hold true for division. Or we could say that rational numbers are not closed under division. Now, additive inverse. What does the additive inverse actually mean? Additive inverse is the number which when added to the same number results in a 0 as a result. So in case of a rational number, when a by b, we have to find the additive inverse of a by b. So clearly, if we add a minus a by b to a by b, the result would be 0. So minus a by b will be the additive inverse of a by b. Multiplicative inverse. What is multiplicative inverse? Multiplicative inverse is the number which, when multiplied by the given number, will result in a 1. So we can clearly say that a by b, when multiplied by b by a, will result in a 1. So b by a will be the multiplicative inverse of a by b. So we can say that the multiplicative inverse of any rational number would be its numerator and denominator switching places with each other. Moving on to some more properties of rational numbers. Let's talk about commutative property. Now, what is commutative property? Commutative property states that if you change the order of operation, if you reverse the order of operation, the result remains the same. So that means if you add a to b or you add b to a, the result would remain the same. Yes, it would remain the same in case of rational numbers also. But when we talk about subtraction, it is not the same. Let's take an example. Let's take one rational number is 1 by 5 and the other rational number is 1 by 8. If we subtract 1 by 8 from 1 by 5, the result is 3 by 40. While if we change the order and we subtract 1 by 5 from 1 by 8, the result would be minus 3 by 40, and clearly 3 by 40 and minus 3 by 40 are not the same rational numbers. So we can say that rational numbers do not hold the commutative property true for subtraction. It holds it for multiplication, but again, if we see it for division, a by b divided by c by d would not be equal to c by d divided by a by c. Let's take, for example, if we take two rational numbers, 2 by 3 and 4 by 5, if I divide 2 by 3 by 4 by 5, the result is 10 by 12. But if I do other way around, if I divide 4 by 5 by 2 by 3, the result is 12 by 10. And again, we see that the results are not the same. So this means commutative property does not hold true for division of rational numbers. Okay, now let's move on to associative property. What does the associative property say? Associative property says that if we have an operation of the type A plus within brackets B plus C, this would be same as if we change the order of the operation by changing the brackets. If we make it in bracket A plus B and then plus C, it'll remain the same. So yes, that holds true again for addition. But when we move to subtraction, a by b minus c by d minus e by f in bracket is not the same as subtracting c by d from a minus b and then subtracting e by f from the result. Let's see how. If we take three rational numbers here, 5 by 8 minus, then 1 by 4 minus 1 by 8 is in bracket. That is giving us 5 by 8 minus 1 by 8, which is 4 by 8 or 1 by 2. Now let's change the bracket and then see what happens. So if we subtract 1 by 4 from 5 by 8 first, that we get 3 by 8, and then we subtract 1 by 8 from 3 by 8, we get 2 by 8, which is 1 by 4. And 1 by 2 and 1 by 4 are not the same. So rational numbers are not associative under subtraction. And similarly, if we see that they are associative under multiplication, but under division we again have the same issue. When we change the brackets, a by b divided by c by d divided by e by f, it is not equal to first dividing a by b by c by d and then dividing this result by e by f. We again take the same rational numbers and let's see what happens. If we do 5 by 8 divided by 1 by 4 divided by 1 by 8, we're getting 5 by 8 divided by 2, which is 5 by 16. But if we move the brackets to 5 by 8 divided by 1 by 4 first, we get a result of 5 by 2 and then divide by 1 by 8, which makes it 20. Now 5 by 16 and 20 are obviously not equal, so we can say that rational numbers are not associative under division. Continuing with the properties of rational numbers, what is additive identity? 0 is the additive identity of rational number. What is additive identity? Is any number which when added to a rational number does not change the rational number. So that clearly is 0. When you add 0 to any number, the number remains the same. So that is additive identity. Multiplicative identity is the number which when multiplied with the given number does not change the number. That clearly again is 1. If we multiply any given number with 1, the number does not change. So it's true for the rational numbers. Now let's talk about the distributive property of multiplication over addition and subtraction, which means a multiplied by within brackets b plus c is equal to a multiplied by b plus a multiplied by c, and for subtraction it becomes a multiplied by b minus c is equal to a multiplied by b minus a multiplied by c, and that rational numbers hold this property true. Now let's try and understand some techniques for solving the questions related to rational numbers. Now first thing while dealing with rational numbers is we should try and bring the rational number to its simplest form. And how do we do that is by dividing the numerator and denominator with a common factor so that we get the simplest form of the rational number. Then we use the properties of rational numbers to simplify them. The properties that we just talked about, the commutative property, associative property, distributive property, all these properties we use so that we can get a simplified rational number as a result. Now, if the expression to be solved is a mix of decimal and quotient form of rational numbers, then it is always advisable to change the decimal number to the quotient equivalent first and then simplify using the above two methods so that we get a final quotient form of rational number, which if possible or if needed can be converted to the decimal form also. Now let's move on to the quiz, some quizzes on the rational numbers. Now we've studied everything that we do with the rational numbers. Let's try and solve some of the questions. Can we find the square root of 0.00289 by 0.00144? And the options are given here. So let's try and solve them, and after we move on to all the quiz questions, we'll look at the solutions also. The second question is, let's try to simplify 32 by 6 multiplied by 0.00289 3025 plus, then within brackets we have 16 by 3 multiplied by 1 by 100 plus 7 by 3. Now we need to use all those properties and other things that we've discussed to simplify this to get an answer which is true, which is one of these. And the third question on rational numbers is convert this decimal 1.3585858 and so on to its PQ form. And again, this is of the type which is non-terminating, mixed, non-terminating recurring decimal number. So the choices are here, and we need to try and do it using the method that we talked about. Let's look at the solution for all these questions that we have given in the quiz. So you try to find out the square root of this number. We'll first convert the decimals to their P by Q equivalent, which would look like this, which make it 289 by 1 lakh divided by 144 divided by 1 lakh. So this is what we have to. So if we change the division to multiplication, and it becomes 289 by 1 lakh multiplied by 1 lakh by 144, which comes out to be finding a square root of 289 by 144. Now we know that the square root of 289 is 17 and the square root of 144 is 12. So the square root of P by Q is also equal to square root of P divided by square root of Q. So here is what we get is the answer. So option C is the correct answer. Let's look at the solution for question 2. Here we have a question again, we have a mixture of brackets, we have a mixture of decimal numbers plus the P by Q form of rational numbers. So first we'll change the decimal number to its P by Q form, and here is what we get. We try to simplify. We try to bring the rational number to its simplest form, which is bringing this number 3025 by 10,000 to its simplest form, which becomes 121 by 400, and also 32 by 6, bringing this to its simplest forms gives us 16 by 3, and everything else was already in its simplest form. So now we use the associative property, which says that we can change the order of operation. We can move the brackets and we can change the order. This is true only for addition. So here that we are performing all the additions, we can use the associative property easily. And why do we actually do that? The reason is that we see a 16 by 3 as the common thing in both these terms. So now if we are trying to bring them together, we can take out 16 by 3 as the common factor and then simplify the remaining part of it. So that is the reason why we are trying to use the associative property here. So if we use the associative property and then bring out the common factor, which is 16 by 3 out, and then we get 16 by 3 multiplied by 121 by 400 plus 1 by 100, and this is basically using the distributive property over addition, and we keep 7 by 3 as it was. So now simplifying this, we get 16 by 3 multiplied by 125 by 400 plus 7 by 3. Now simplifying this, now we simplify because 125 by 400 is not in its simplest form, so we divide it by 25 and we get 5 by 16. So we get 16 by 3 multiplied by 5 by 16 plus 7 by 3, and this can further be simplified to 5 by 3 plus 7 by 3, which is equal to 12 by 3 and hence equal to 4. So in this case option B is the correct answer. Now let's do the third question. Convert the decimal 1.3585858 to its P by Q form. Now as we had done in the presentation itself, in the video, in the previous part itself, let x be equal to 1.3585858, and then we say 10x is equal to 13.585858. Now if we see in the first and the second part, if we subtract first from the second, the decimal part of the two is not the same, so we'll still get something as the decimal part, so that would not be advisable. So now what do we do again here? So now if we see there are two decimal places which are getting repeated, we have 58 which is getting repeated here. So can we do one thing? we multiply this by 100 and we get 58 also on the left hand side of the decimal. So let's do that. We make it 1000x is equal to 1358.585858. Now if we see in these two terms, the decimal part is the same. Now we can subtract 2 from 3 to get 990x is equal to 1358.585858 minus 13.585858, which is equal to 1345, and x is equal to 1345 by 990. And of course we can, if the choices would have been like that, we could have further brought it into its simplest form, but since the options are like that, we say that option D is the correct answer. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.